Okay, so we have a cone of base 30 millimeters and as is 50 millimeters long that is resting on its base on the horizontal plane. It's cut by a section plane perpendicular to the vertical plane and inclined at an angle 45 degrees to the VP. The section line passes through the left generator at a distance of 25 millimeters from the base of the cone. We want to draw the lateral surface. So first we draw in the base, or we draw in the top view of the cone. Then we divide that into a certain number of equal parts. And then we use other test or M test tool, and then we kind of label the first divisional point. Now we select that line and then we want to array it. That's polar array. To get 12 divisions. And then we will get the test and then polar array it once more. And then we want 12 points as well. Make sure associative is off and rotate items is off. And then I'll select the test in the specific order in which I am selecting them. So would select them all and then use T count to update them. So type T count, click on select order. We're beginning at 1, spacing is 1, so 1 comma 1, then click on overwrite and that will do the job for you. Then we can switch the layer to maybe the object layer or any layer that you've created to draw your object lines on. So at any convenient distance, I'll draw the front view of the cone. That's quite too close to the base, so I'll move it up just a little bit. Then I'll switch the layer to maybe AM_7, which is the center line, and click on line. Now at the midpoint of the line, I'll type in 50, which is the axis height of the cone. And then from that axis, let me switch back to object. I'll click back on line, and then with the line command, I'll draw these two lines to represent the generators of the cone. Let's switch back to AM0. Then what I want to do is I want to project those points, so 1, 2, 3, and all that. So 2 and 12, I project that, and then 3 and 11, I project and draw that to the apex. So you have the both of them going to the apex. And then on the other side, it's going to be the same kind. So I'll just select those two and mirror them, right? So 5 and 6, I mirror them to the other side using the axis as my mirror line. Then I can switch the layer. I'm trying to draw in the The cutting plane is 25 millimeters from the base, so I draw a horizontal line 25 millimeters from the base, and then with the line 2 I draw some line at that point. Make sure my ortho mode is off, and then the angle should be 45, right? So that's what the question said, that the cutting plane makes an angle of 45 degrees to the left generator at some point, which is 25 millimeters from the base. So that's how we get that. I extend those lines a little bit, and because in AutoCAD Mechanical I already have a section plane, I'll just go to I'll go and click on that icon. That basically gives me a cutting plane, so I can click there and then click on the side. Now I can click to position that, and that basically represents my cutting plane. All right, so for the label of the cutting plane, I'll just double click on that, and then in the identifier I'll change it to X, and then in the label content I'll delete that. I don't want that, and then just click on OK for now. What I want to do, I want to move the arrow, so I can click on that part of the line and then click on the arrow and then move it a little bit to the edge. Maybe I'll extend the cutting plane itself a little bit. So maybe we click on it, click on that snap, and then move it out a little bit. That should be fine now. Okay, so I'll copy that and then position it there. I want to label the points on the front view of the cone, so that will be point 1. I'll just copy those. So I'll copy that, turn on snap, copy that by that point, and then move it there. Click to position them. So I just selected them all, went to quick properties, and then I want to make them smaller, so I'll choose maybe a height of 1. So that point there should be 2 and 12. Let's move it to the left. All right, so I just edited them all to correspond with the points on the top view, so you can edit them accordingly. So I'll now go for line, and then point 1 goes through there, point 2 goes through that point. All right, so I'm just projecting the points to the generator on the right, because that's where I get the true length. So point 3 and 11, I project that horizontally, and then point 4, project that horizontally, point 5, project those as well, and then point 6 is right there. Now make sure you get the correct point and then project it to the generator. It's very important that we do this, because that's how we get the correct or the true length. Okay, and then I'll position some points there, so PO for points, and then I'll position some points at the exact locations where my projectors are cutting through the right generator. Let me trim the extraneous parts. Mind you, I'm using the cutting edge method, so I'm using the right generator as my cutting edge. Take notice of these points. I'll select all of these points one after the other, and then select the right generator, which is the true length of the side of the cone, and then seal for copy. So I'll copy those, and then I would begin to now draw the lateral surface that is required. I'll just change that to object layer, which has no thickness. And then what I want to do is I want to polar array the line, but in any case the length of the line is very important, that we have the length of the line, so that's 52.2, because we're going to use that for some calculations. So I select the line, and then I array it, that is polar array. So we select the line and then polar array, then use that as the midpoint. We have to, I want 13 items. I have 12 divisions inclusive of the original, so that's 13. And the inclusive angle, I have to calculate that. So that's radius divided by the length of the generator, or the length of the slant height of the cone, multiplying all of that, multiplying 360 degrees. So the radius of the base is 25 divided by 52, which is the length of the slant height, all of that multiplying 360 degrees, and that's what I'm typing in there. So you type that in there, that is R over S multiplying 360. And you hit enter or something, so you see that the angle is 172. If you calculated that, you see that you get the same angle. Okay, so I have the number of divisions required. Okay, so I'll switch to another layer. It's kind of a constructional layer. So I'll draw some circles. The center of the circle is the vertex. And then, mind you, that first point there corresponds to 1, if you recall. The next one corresponds to 2. It's not only 2, but rather that's 2 and 12. And then the next one, that's 3 and 11. And then 4 and 10. 5 and 9. 4 and 8. Then 5 and 7. Okay, So we have all that, and then I'll go for trim, use the cutting edges, and then click there and click there, and those are my cutting edges, and then I trim to get that. Now I'll position some points at the required location. So I'd go for PO or something. So PO for point. Then 1 and 1 is already there, the last one. So this next one will be 2 and 2. This one will be 3 and 3. So 4 and 4. 5 and 5. 6 and 6. And then finally I would have 7 and 7. What I mean by those combination is line 7 and axis 7, that's what I mean by 7 and 7. Okay, so I'll go for the object layer, and then I'll select center, start, end. I want to draw the base, the lateral view of the base, so center, and then start, and then I'm going to end it there. So that is the lateral surface of the base, or that represents the base. And then for the part that I'm sectioning, let me copy the labels and then bring them here. Just put it on layer 1. I'll select that and then polar array it. And the center point, of course, is going to be that point. And what I want is 13 items like I did earlier. Now I'd have to use the same calculations. So it's R over S all multiplying 360. And R is radius of the base, which is 25, divided by the slant height, which is 52.2, all multiplying 360 degrees, just like I did earlier. And then 10 of 48 items, and I'll have those and then close. So I'll select all the labels in the order in which I'm doing them. It's very important that you follow the same order. And then you type T count. Spacing is 1 on 1. You click overwrite. And then the labels will be updated. Now mind you, the very first label was not selected. So I'll select the object layer and go for spline. So that is point 1 and 1. So that's point 2, point 3. That should be 4. Now 5, 6, and 7. 7 is midway through, so I won't continue. I'll just get the first 7 and mirror to get the other part. Alright, so I have that. I want to select the point and then select the line itself or the curve itself. all those points I would select, and then mi for mirror. And my mirror line is line 7. So any 2 points on that line will give me the mirror line required. So I mirror those and I get the cutting plane, in the lateral view. And then I can turn off that layer to see my work more clearly. And then I'll use the object layer and line to draw in the required, object lines, which will be the folding edge. Now I'll select those lines and mirror them to get the lines on the other side. Okay, so that's about it. Now what I've done is you double click on that, you go to the settings. There are several things you can change. You can change that to ISO, for instance, and that gives you the XX in white. And then mind you, I've also updated the labels. Now that point there I've labeled as 0, and then I've also put in these labels A, B, C, D, all the way to A. And that basically is the solution required.